Hey Chem 30s. Sorry, I'm running a little late today. It's just one of those crazy days. Okay, so we've learned about some basic organic molecules. We've learned about alkanes, we've learned about alkenes, we've learned about alkynes, and even aromatics. Now, the next thing we need to talk about is isomers. So isomers in organic chemistry are where you have one molecule, and you can have different forms of that molecule.
Oh, hey man, are we working on that isomers video now? Like, I was just getting ready to help you with that.
Okay, not now.
Can I,
try to make my videos. You go back.
Oh.
I'll help you beat the level later.
Okay, whatever. Like,
It's
relax.
I don't have time.
Chill
for this,
out.
Okay, I don't have time for this right now. I'm trying to make my isomers video. I said no. Okay, I said no. Okay, just no. So weird, right? What a weird guy. Okay, so isomers are different forms of a molecule. So in order to make two different isomers, two different structural isomers, those are the type we learned about in Chemistry 30, you need to take the same number of carbons and hydrogens, but arrange them in different ways. So I have this molecule here. Take a look at it. It's got 4 carbons. It's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. This is butane, classic butane, right? So what other molecules could I make with 4 carbons and 10 hydrogens? Well, if I took off this carbon on the end and I reattached it to this one instead, I still have 4 carbons, I still have 10 hydrogens, but they're in a different arrangement now. Now, if I were to name it, it's got 3 carbons in the parent chain, and it's got 1 as a methyl group. This would be methylpropane. The fact that it has a different name means that it's obviously a different molecule, so it's not the same molecule, but because it has the same general formula, same number of carbons and hydrogens, C4H10, that means that this is an isomer of butane. And in general, the larger that molecules get, the more isomers that will exist of them. Structural isomers are molecules that have the same molecular formula but different structural formulas. So the atoms that they have are arranged in different ways. Example of this is butane. Butane has got 4 carbons, 10 hydrogens. So those 4 carbons and 10 hydrogens could be arranged like butane, CH3, CH2, CH2, CH3, or they could be arranged like methylpropane, where I take one of the carbons on the end, CH3, and I can move it onto this central carbon. My carbons are all still happy. They've all got full bonding capacities, right? They've got 4 bonds. There are still 4 of them, and there are still 10 hydrogens. So I've still made a nice, balanced chemical formula. These are the only 2 isomers of C4H10. You could say, well, couldn't you take the methyl group and put it onto this carbon? And you could try, and that would be a common thing for people to try. They would say, okay, I could make this molecule like this, where it's got a methyl group and a propane backbone, but the methyl group's in a different spot. But you might notice that that molecule, when you move the methyl group over here, you actually extend the backbone. So what you have drawn is just butane again, but laid out in a different way. So this is really just butane again. It's not a different isomer. So when you're doing your investigation, you'll have to watch out for ones like that that look like they're different, but they are actually the same molecule. And if they end up with the same name, butane, then they're not isomers. They're just the same molecule.